Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will develop this function f of x is equal to e to the power of x divided by 2 using the Maclaurin series, and then we will determine the convergence interval. So, we know the Maclaurin series is of that form. Maclaurin series is equal sum when n goes from 0 to infinity of the nth derivative of the function, but when we replace x by 0, x to the power of n divided by n factorial. So if I have to bring that function f of x equal e to the power of x divided by 2, I have to find the derivative of that function and then to find the nth derivative when x equal to 0. So let's start by doing f prime of x. We know the derivative of e to the power whatever, it is e to that power multiplied by the derivative of x divided by 2. So the derivative of x divided by 2 is 1/2. And if I want to replace x by 0, so I would have f prime of 0 is equal e 1/2 times e to the power of 0 divided by 2, which is 0. And anything to the power of 0 is equal to 1. So f prime of 0 is equal 1 times 1/2 is equal to 1/2. So now let's bring the second derivative of e to the power of x divided by 2. We know that the first derivative is this one here. Let me highlight it. So this is the first derivative. Let's bring the second derivative. So f second of x is equal, I have the 1/2 here, which is a constant, I keep it. The derivative of e to the power x divided by 2 is e to the power x divided by 2 multiplied by the derivative of x divided by 2, which is 1/2. That is equal 1/2 to the power of 2 times e to the power x divided by 2 and f second of 0. Again, if I replace x by 0, I would have 1/2 to the power of 2. And let's do the third derivative. Again, I have 1 to the power of 2, 1 divided by 2 to the power of 2 is a constant, I'll keep it. And the derivative of e to the power x divided by 2 is e divided by x divided by 2, multiplied by x divided by derivative of x divided by 2, which is 1/2. So it is equal 1/2 to the power of 3 e x divided by 2. So now I have a third of 0 is equal 1 divided by 2 to the power of 3. So from here, we can deduct the f to the power of n of 0. So the nth derivative of f of x, when we replace x by 0, should be 1 divided by 2 to the power of n. And so now I have this from the Maclaurin series. I know the first term is f to the power of n to the f of 0 to the power of n. So I have it now. So if I want to rewrite the Maclaurin series, so it is equal sum n equal to 0 to infinity. And instead of f, the nth derivative of f of 0, I can write 1/2 to the power of n multiplied by x to the power of n divided by n factorial. So here I developed my function f of x e to the power x divided by 2 using the Maclaurin series, and I have it. Now we have to study the interval of convergence. For the interval of convergence, I have to find the nth derivative of that series when x is equal to 0. So here, if I replace x equal to 0 of of that, the Maclaurin series, I would have sum n equal to 0 to infinity 1 over 2 to the power of n divided by n factorial, and here 0 to the power of n is 0, 0 to the power of whatever is 0, so I'm not gonna write it. So looking at this, I realize that this is the Taylor series, and for exponential function, it converges for all x belong to R, the real numbers. So because it is Taylor series, the Taylor series converge for whatever x belong to the real number. So it converges for all x belong to R. So the interval of conversion is from minus infinity to plus infinity. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.